In today's episode, we're talking to Nate Barbettini about the rationale behind OAuth and OpenID Connect in plain language and explains when and how you should use them. Make sure to stay until the end. We're giving away the Udemy course, The Nuts and Bolts of OAuth 2.0 by Pirecki to 5 of our live attendees. Hi, I'm Stefania, aka DevStepOps. I'm joined by my co-host Nikki, and you're watching the OWASP DevSlop Show. If you can't stick with us until the end, do not worry. The recording will remain available on our channels. Link to resources we'll cover today will be added to the description box below right after the stream. Make sure to give us a thumbs up and subscribe.
Guest is Nate. Whoop, can you hear me? Yeah. Hey everyone, I'm Nikki. Welcome to the OWASP DevSlop Show. Today's guest is Nate Barbettini. Nate is the CTO and co-founder of Cobbler, where he leads a team building financial analysis software for enterprise businesses. Previously, he was a product manager at Okta, focusing on making security and authentication easier for developers. He's a former Microsoft MVP and the author of the free little ASP.NET Core book. Welcome, Nate.
Thank you very much for having me. I'm excited. Thanks, Nikki. Thanks, Stefania. Like Stefania said, today we are going to be talking about OAuth and OpenID Connect. Those are topics that tend to be pretty confusing. A lot of difficult terminology and jargon around them. So I'm excited to dig in. My goal today is to start at the high level, talk about why these standards exist, try to help everybody fit them into the big picture of where you should think about using them, maybe where you should not think about using them, and then dig down into some of the technical details, explain how they work under the hood, help you understand how to implement them in your own applications or your own projects, and of course, answer as many questions as we can from you all watching today, this morning or this evening, wherever you are. So thanks for joining us. Let's dig in. So the first thing to talk about here is we got to get a big caveat out of the way, a big disclaimer. There's a lot of confusion about this topic online. So if you've ever tried to learn about OAuth, or you've heard about it, or you've even tried to use it maybe, and you found yourself confused by how much difficult terminology and jargon exists out there, you're not alone. It's not you. It's a very confusing topic. It was very confusing to me when I started in the security industry. And I actually I wrote the first version of this talk because I was so confused about it, and I was trying to think, how do I figure this out? I need to understand this. Maybe if I write a talk and to help other people understand it, maybe I'll understand it better too. So I just wanted to get that out of the way because this is a topic that I think intimidates a lot of people, and to make matters worse, if you have the misfortune of like Googling, what is OAuth or how does OpenID Connect work, things like that, you'll find not only all this difficult jargon and terminology, but you'll also find actually very contradictory or conflicting advice online. You might find like one Stack Overflow post that says, here's the right way to do OAuth, here's what you need to do, and then the very next link will be somebody else's blog that says, no, they're totally wrong. You should not ever do it that way. That's wrong. You should do it this way, and this is the right way to do it. So that that doesn't help.
And most security people are taught like, don't roll your own authentication or authorization, right? And then you start Googling around for open standards, and you're like,
wait,
whoa. So this is great.
Yeah. Unfortunately, there's nothing worse than a standard that doesn't actually have a reference implementation, and a lot of times that's true for OAuth, and for some reasons that I think will be a little bit more clear after we get into it. But it's a confusing topic. What I've found is I think the easiest way to understand how OAuth works and also kind of where it fits in and why it's so confusing at times, it's really helpful to understand the why. Why does it work the way it does, and also why is it built the way it's built? So to understand the why, we need to go back in time quite a bit to kind of the simpler days of the internet, I guess you could say. way back in like the early to mid 2000s, there was a problem that started coming up on the internet with internet applications that was, some people called the delegated authorization problem, but that's just a fancy way of saying we have a situation where there's actually multiple systems that want to talk about and deal with a user's data, but we don't have a secure way of letting those systems interact about that user in a standardized way. A great example that's kind of a little bit infamous now, I guess, but way back in the day when Yelp was first getting started, also when Facebook was first getting started, it was really common pattern in like sign up flows for these web apps to ask for like, create a username and password, sign up for the app, and then they would ask you, hey, if you want, we can go look at all your contacts and find out if any of your friends are already on Facebook or already on Yelp, and we'll like connect you automatically. So that's kind of cool, if you want to be connected. But the way that they did it, and you can see in the screenshot, is they would ask for your Gmail address or your email address and your email password. And then the application would actually go log in to like Google on your behalf with your real Google password and like, pinky swear that we aren't going to go do anything else with your data. We're just going to look at your address book and get those contact emails, and then we're going to throw away your password and we won't keep it. Now, regardless of how you feel about trusting Facebook or Yelp or whatever, this is just an extremely bad practice. Put a big old X in front of it just to say like, you should never do this.
You've literally given me goosebumps on my arm hearing that in his face. I'm like, oh my God.
These are the things that like, if you're in AppSec, I think these kind of things like, keep you up at night, wake you up with cold sweats. Without belaboring the point too much, giving somebody like the real password to your email account is extremely bad practice, because like, even if you 100% trust them that they're not going to do something nefarious with it, who knows if they have a bug in their software? Who knows if they get breached? Who knows if they have an intruder in their network watching this stuff go by? Like, it's a terrible practice. Now, in this case, I'm using this as an example, but I'm not trying to pick on Yelp too much. There was not a better way to solve this problem at the time. It was just only a bad way to solve the problem. But the problem still existed, that there was a desire to have a way to securely do this without having to blast your email password to, everybody and anybody. And that better way, ultimately, to make the long story short, the better way to do this ended up becoming the OAuth standard. So what you might be familiar with seeing now, because it's so common, is instead of this, you see a website asking you, oh, click this button to go connect to Google. And then Google asks you, are you sure you want to allow XYZ, whoever, to have access to only, this bulleted list of things? And you're allowed to click yes or no. That screen that we all have become much more familiar with now is actually, that's the user-facing side of OAuth. Under the hood, that is what OAuth is. A way to say, okay, I'm building Yelp or the next whatever. I'm not trying to get access to all of your stuff. I'm just trying to get access to one bit of things that I'm going to ask you permission to get access to. And OAuth is what allows us to do that. Now, sorry, go ahead.
Yeah, no, I think it's, if you go back just one slide, like that keyword authorization, I feel like a lot of the confusion, at least I've experienced personally and other people who I've spoken with, is around, is OAuth an authentication protocol?
Yeah.
It is not an authentication protocol.
It is not. It is not. We'll talk about that a little bit more in a second when we talk about OpenID Connect, which is an authentication protocol. But for anybody who's confused about what that means, there is a big difference between authentication and authorization. Authentication is what you'd think of as like signing in, logging into something. It's who you are. You have to provide like your email and password to log in. That's authentication. Authorization is what you're allowed to do after you've logged in. And OAuth, at least the original use, the original scope of OAuth was all focused on just authorization. We're not trying to log the user in. Presumably the user already can log into Google or whatever. But what we're trying to do is say, can the user say that you have permission to do this one little thing or these two things? but in a structured way that lets two APIs that are totally different systems communicate about it, because they both speak the same standard, basically. But you're absolutely right. It was jumping ahead a little bit, but it was immediately abused, or very quickly abused, to try to turn it into an authentication standard, and that's where a lot of the confusion comes from. So another kind of way to, or thing to set the stage on is a lot of times when we're talking about OAuth and also OpenID Connect a little bit later, you'll hear terms that are talking about, you'll hear terms like three-party flow or a three-party interaction. And that is an important distinction of when we're talking about these standards, specifically OAuth, we're often talking about multiple systems that need to interact, which is very different than just one system and one user interacting. So if you, to illustrate that, if you, for example, are a user like me or you, and you're interacting with like the Google Contacts app yourself, you're just, maybe hitting the Google Contacts API or just using the app to add or remove a contact, we would call that a two-party interaction. It's you, sometimes called the resource owner because it's your data. You are interacting with Google. Google has an address book and you're interacting with that app. That is, again, what we would call a two-party interaction, and that is actually not a situation where you typically would see OAuth, because it's honestly really simple. Like, there's probably some authentication between you and that API, but pretty simple. Where
so
the problem...
just on the simple use case, so you authenticate, and because it's your data, you have the authorization to do what you want. So it's kind of like tick for both. Cool.
Yep. That's like, obviously, I don't mean to like paper over the fact that there's plenty of complexities in just that alone, but that's kind of a different topic outside of what we're talking about today. The need for OAuth and more complex standards arises when we have three parties or more involved, where it's not just you using the Google Contacts app, it's you using some other application, and that other application wants to go talk to the Google Contacts API on your behalf. So now there's three parties or even more kind of all in this big dance that are still all centered around your data, but it's not just you interacting with a service, it's you interacting with a service that's interacting with another service, and they all have to be kind of on the same page about what you are allowing them to do with your data. So you'll hear me mention those terms like three-party interaction, sometimes called three-party flow. That's all it means. We're just talking about more than one system involved here, and that's kind of where the need arises to have a standard for dealing with expressing permissions or transmitting permissions between systems, because it's not just you and an API anymore, it's you and another one and another one. So, so Nikki kind of already hinted at this. What happened after this standard was introduced, there was a couple of iterations. OAuth 2.0 ended up being the iteration of the standard that really caught on. It became very successful. It became super widely used to solve this problem, and it still is used today. Really successful, kind of became a victim of its own success in a way, because it started being used so much that people used it for stuff that was like pretty outside the original scope of what it was intended to be for. As Nikki said, it was intended for authorization, which is distinct from authentication. But I forget when it was, 2011 or something, when the social login idea kind of came onto the scene. Facebook and Google and others introduced this idea where you already have a Facebook account or you already have a Google account, so don't even bother setting up a new username and password on every single site. Just click a button that says sign in with my existing Google credentials and I'm in. Super convenient for users. Under the hood, they implemented those buttons with OAuth because it was really common. It was like almost did all the things you need to implement something like that. But because it was OAuth under the hood, that pulled OAuth into the realm of also trying to solve authentication use cases beyond the original authorization use cases. And that caused a lot of the problems and confusion that we see today.
Yeah.
So when you Google for it, half the time you're going to be seeing people talking about trying to solve authentication problems, and half the time you're talking about solving authorization problems. It's really unclear which context people are talking about these standards in.
And just to drill into that a little further, because I think a lot of people initially understand OAuth or OAuth 2 via social login. I could be wrong on that, but it feels like it's a common use case and people are very familiar with that. Just to drill into this a little further, if I authenticate with Google or Facebook to a service, do I have an account on that service? Like I'm authenticating to Google and Facebook and authorizing them to do what on that service? Like how? Yeah, just to make it clear for the audience.
That is, it gets blurry for sure. So if let's say you use a social login button to sign up for some service that you haven't used before, you are both registering for the service and also authorizing some information from the provider like Google to be transferred to the service. Now that information you're authorizing might be just like your basic profile information, like your email address, but that counts as authorizing some information. I think what a lot of people might not understand at first or miss at first is that even with the convenience of one of those social login buttons, there's still a lot of stuff that the client application needs to do. It doesn't replace having, a database for storing users who have registered or keeping track of users who have registered or things like that. It's really just a mechanism to kind of get in the door, and you still have to have the rest of kind of a registration flow or a database to store all that information, and you still have to implement that on the client side. Let me know. Cool. Let me know if that answered your question.
Yeah, no, it was good. Again, just trying to just offer the areas where I feel I've experienced either confusion or seen people get confused by this. And I think you're right. That explosion of that social login button really polluted the conversation here in a confusing way, like as to what is actually going on under the hood. So
it really did. Yeah. That's a good word. It polluted the conversation in an unfortunate way. And I know that it may seem kind of like an academic distinction, be like, authorization, authentication, like at the end of the day, you just you need to get some information from one system to another, right? It is kind of an academic distinction, but it's still an important distinction because specifically there are things that you care about during authentication that you actually don't care about for authorization. A big one is for authentication, you really, really care about who the user is. Like you need to, authentication is no good if you don't get back their email address or something. You need to get some information about the user who just logged in. Whereas with authorization, you don't actually care who the user is. You care what you're allowed to do on behalf of the user, but it doesn't if they have an email address at google.com or at whatever.com, it doesn't really matter because you're past the point of caring about who they are. You only care about what they can do.
Cool. We have a question on this topic from the audience. So from Yoni Guriniwan, why separate authentication and authorization? Why is it bad to use OAuth for both?
Good question. It's important to separate them at least conceptually because they're really intended to do different things. Authentication is intended to identify who the user is. Who just logged in, for example. Whereas authorization is all about what the user is allowed to do once they've already logged in. So one is kind of the who and one is the what. Now, you're right that they are they're similar and often they're kind of discussed as two sides of the same coin because it's all kind of zooming out. You can call it all part of identity, solutions about the user. But specifically on the topic of OAuth, when we get into the technical details, I'll point out some of the specific areas where right now I'm just saying, OAuth wasn't super great for authentication. It was missing some stuff. I'll point out exactly what was missing and why there needed to be an additional standard, which we call OpenID Connect, built to solve that. But for now, the short answer is that OAuth there's no way in the OAuth standard to find out who the user is. And in fact, you might be wondering, okay, well, if there's no way to find out who the user is, how do all these social login buttons work, which I already said were built on top of OAuth. The reason why Nikki's expression was so great that it kind of polluted the waters for OAuth was when Facebook and Google and LinkedIn and everybody and their brother built a social login button back in the day, they all used OAuth, but they all had to make their own kind of like extra hacks on top of OAuth to make it work, because OAuth doesn't have a way of like querying who the user is, and you need that for authentication. So that was a known gap. The problem was that every single company that implemented social login did it differently. So now you have a standard, and this, but unfortunately the standard was used in like 13 different ways by 14 different companies. And that means that none of them were interoperable. You could not have a single implementation that just, on the server side, I mean, there was not a single implementation that would work with any social login button. They were all completely different.
Just on that. So you mentioned everyone's doing it their own way, which I understand. So now, has it become a bit more standardized, or is it still that everyone is?
It has, I would say it has become a bit more standardized, but not completely. It's still, I think there's still some cleanup that should be done from the pollution that happened back then, because some of those social login buttons now use the standard that we call OpenID Connect, and that's a much better way of doing it, much more standardized way of doing it. But not everybody has adopted that yet. So Google led the way in a big way by switching their social login button over to using OpenID Connect, and it's been a hot minute since I checked, but I think Facebook does now too. I think the big folks do, but some of the smaller providers haven't made that switch yet, so they still use just OAuth and not OpenID Connect. So it has become a little bit more standardized, yeah, but not as standardized as it would have been if it was like kind of, if this was all in place from the beginning. But you know, organic growth is messy, so it doesn't always go the way you hope it does.
And I think Apple's out of the gate was OIDC and OAuth too.
Yep.
Yeah.
Definitely. It was nice, like when Apple built the Apple ID login, or whatever they call it, sign in with Apple. They had the benefit of building that after all of this kind of messy evolution had happened. So they were just like, they were able to say, nice, like the industry's kind of like figured all this mess out, and we'll just build it like the right way now, which was nice. It was nice to see. I was actually very concerned when I heard that they were building that. I was like, oh man, I hope they don't build it the old way. And I was really happy to see that they kind of built it, quote unquote, the right way. So we kind of already touched on this, but the problem that occurred back then was that OAuth did not have a way of getting the user's profile info or querying the user info, because it simply wasn't, it wasn't built for authentication. It was built for authorization. So querying who the user was never in the scope of what OAuth was trying to solve in the first place. So what happened next was that this kind of big mess happened. There was a lot of growth, a lot of confusion that was created. But OAuth was a very popular and widely adopted standard, which is good for the internet as a whole. Then some of the folks who are kind of involved in steering the standards and writing specs came back together and wrote an additional spec that we call OpenID Connect. And the way that these two standards kind of relate to each other is another source of confusion that a lot of people have. They sound like they're totally different things because they have totally different names, which is kind of unfortunate. But what OpenID Connect is, in terms of like fitting into the big picture, OpenID Connect is nothing more than an additional layer, or really just like a fairly small extension on top of OAuth itself. So maybe you could argue it should have been called like, OAuth 2.0 for authentication or something. It's the name kind of makes it sound like it's a totally different thing. But as we'll see kind of when we go into some of the technical details, OAuth kind of provides the patterns or the standards. OpenID Connect says, oh, great, we're not going to change any of that stuff. People already know how to use this. We're not going to reinvent the wheel. We're just going to add one or two extra things on top that fix the gap for authentication and make it possible to use this same exact pattern that everybody's familiar with for the authentication thing that everybody wanted to use it for in the first place. And it just standardizes that, so we at least don't have a situation where 13 different companies implement it 14 different ways and we have a big mess. So it brings that kind of back into the realm of standards.
So before we hit the next slide, a few questions
Yeah.
in the chat. Okay, so Tyrex Rotail is asking, what is the difference between OAuth and SAML, which I'm fairly certain was probably going to come up. So
Sure.
We could tackle it now, or if you're explaining it later, we could just kind of punt it.
I'm not explaining that specifically later, so now it's great. OAuth and SAML, well, the big difference at a very high level, if we zoom out to kind of the 10,000 foot view, there's a couple of really big differences. SAML is a protocol built for authentication. And I know I'm kind of going to hammer this point home, but OAuth is not. OAuth is actually a fairly lightweight standard that's original use case is just to transmit permissions information back and forth between disparate systems. That is the way you can think about it. And OAuth originally didn't try to kind of like solve like everybody's problems in the universe and the whole kitchen sink. It was really pretty tightly focused on just, can we get two systems that are totally different to talk to one another and agree on what permissions that the user allowed them to have. That's really all it's trying to do. Of course, it's been extended and appended onto over the years, but that was really what it was trying to solve. SAML, on the other hand, was a protocol specifically built for authentication. So in terms of contrast or comparison, the closer comparison is actually between SAML and OpenID Connect, because OpenID Connect is an authentication protocol or standard. SAML is an authentication protocol. SAML is really common, especially in older applications, because it's very common in like enterprise applications, some banking applications. SAML is often used to build what people call single sign-on, where you kind of like log into one portal and then you can click links to automatically log into a bunch of other systems automatically, and they all kind of know who you are because you logged in one time. SAML under the hood is a way to implement that. Now, SAML also isn't used as much anymore. It's not as common, and one of the reasons for that is because it's frankly a pretty confusing and complex protocol all on its own. I know that this conversation is about how OAuth is confusing, but OAuth is kind of like an improvement over how confusing SAML is, because OAuth, now I won't go, I won't belabor the point, but SAML has its own bag of complexity all built in. It requires certain specific things in browsers. It's XML based, so there's like really big fat XML payloads that need to be parsed and generated and signed and stuff. So it's SAML is its own beast.
Yeah, and that's just out of scope here. Okay, one other question. Zoolicious. What happens if I stop using a Google service? Or what happens if I stop using Google service? What happens to my account with that service provider?
Yeah, I think the question here, and correct me if I'm misunderstanding this, but I think the question is like, if in this example I keep coming back to, if I'm using the Yelp application and I'm authorized the Yelp application to access some of my Google data, what happens if I then stop using Google? What happens to my account over on Yelp? Good question. It's important to remember that when we're talking about these three-party flows, like completely separate systems, each system is responsible for its own data in a sense. Like these protocols, OAuth and OpenID Connect, are intended to help different systems kind of transfer information between each other, but they still are separate systems. So I think the specific answer to the question is nothing would happen to the account with the service provider per se. Shutting down your Google account wouldn't like automatically mean your Yelp account got shut down. It may mean that some things that Yelp was relying on talking to Google for about your account won't work anymore. But what exactly would happen was actually completely up to the client application. It depends how they built it. If they built it so that it was correctly disconnected or separated from Google, then perhaps nothing would happen. If you were relying on the Google sign-in button to get into your account, you might have to like add a different way of getting into your account, like set a password or something like that. But the Yelp application in this example still has its own record of your account, right? it may be a record that's like tied to a Google ID or something, but it still has a record of your account. So it's impossible to answer the question completely because each application might do it differently. But generally, like somewhere between like nothing would happen to the account, or maybe some things would stop working depending on what it was relying on.
Or they would just prompt you, hey, we need you to reconnect them, or
Correct.
remove it. Yeah. And then there's one more question, which I'm fairly certain we're going to get to in a little bit, by the podcast. Hello, how is an app using OIDC creating user sessions, and how is the app session linked to an OIDC provider for that user?
If we have time, can we come back to that question at the end? That's a good question. It might be a little easier to answer once we go through some of the technical details.
Definitely. Let's keep going.
All right. So the one thing I want to cover before we get down into the weeds of the technical details is kind of filling out the big picture and setting the stage to understand when you should use one of these standards and maybe when you don't need to use one of these standards. Because a lot of times I talk to people and they just kind of think they must use OAuth in their project or in their application, when in fact maybe they don't even need to use it. Because despite, hopefully this talk will clear up a lot of confusions, but it's still a complex piece of technology. There's a lot of implementation details that can be tricky to get right. And if you don't need to do any of that, it's great to just skip it, right? So I wanted to fill in some of the high level gaps and explain kind of like the rules of thumb that I use to understand when I should use OAuth in a project or something I'm working on and when I don't need to. So we've kind of touched on some of these already, but you should consider using OAuth in your code or your project or your pipeline or whatever, if in a couple of cases. The biggest one is if your code or your application is connecting to another service and that service kind of makes you use OAuth, then you definitely have to use OAuth. So great examples here are, I've been using this Yelp contact list example a little bit, but another great example is like, I use Google Photos to store photos of my daughter to share with my wife, and sometimes I want to send those photos to like a physical photo printing store. And instead of having to put those on a thumb drive and carry it over there, I might be able to click a button to let that photo printing store link to my Google Photos account and just have access to like only the photos I let them have. Doesn't mean they have access to my Google Mail. It doesn't mean they have access to my Google Drive or anything. They just have access to the specific stuff that I let them have access to. Super convenient for me. It works really well. That's a great example of OAuth helping different systems connect and transfer limited data about a user. Also, if you're building like a Reddit bot or a Discord bot or something where you want the user to be able to log into a service and then you do actions on behalf of that user, on Reddit or on Discord or whatever. A lot of those kind of big APIs use OAuth to make that possible to build third-party applications. And if you are a third-party application developer, you would talk to that API, you get what's called a scoped access token via OAuth, and then you do what you need to do. You do your magic. So you definitely use OAuth in that example. And on the kind of the same coin or different side of the same coin, if you yourself are building the service, you're building the Reddit or the Discord in this example, and you want third parties to be able to interact with your API, then that's another good reason to use OAuth, because people are very familiar and comfortable with using OAuth in these examples. If somebody else is building some kind of integration or third-party app and they want to connect to your API to do some stuff on behalf of one of your users, then OAuth is a good way to do that. Similarly, with OpenID Connect for authentication, if you want your app or your website or whatever to use another service for authentication, like you want to have that sign in with Google button for convenience for your users, then sign in with Google uses OpenID Connect, same with sign in with Apple as we discussed, then you would be implementing or using OpenID Connect to make that work for your users. Different side of that same coin, if you are building the service and you're building like an application and you want to have a suite of applications that have a single sign-on experience, or you want people to be able to sign in with their credentials in your app for other apps, then OpenID Connect is a good way to solve that kind of problem. But I mention all this to say what's missing here is some of the simple cases. Like if you're just building a website or an app and you want like users to be able to sign in with, just like an email address and password or something, you probably don't need OAuth for that. You probably don't need OpenID Connect for that. It's honestly a lot simpler to build that with just like cookies, kind of tried and true. Obviously you want to do that in a secure way, follow good best practices around information security, but tried and true way of logging users into a mobile app and logging users into a website don't necessarily need to have anything to do with OAuth or OpenID Connect. Similarly, if you are building an application where permissions authorization is a really big concern, and you want to make sure that users have really limited permissions with regards to their own data or other people's data, that's really important. That's awesome. Your application should have a good data model around permissions internally, but that doesn't necessarily mean you're using OAuth unless there's a third-party application involved. If we're talking about a three-party flow, OAuth, yes. If we're talking about just a two-party flow where it's like your app and one user, then you probably don't need OAuth. So all that to say, I wanted to make sure we covered this before we get into the technical details, because it is important to understand when all of this complexity that we're going to discuss may not even be necessary for what you're doing.
Sure. So just to this is my way of paraphrasing. I think of it, I think you already said it, but I always think of it in terms of houses. I always think of all tech like this, but your authentication, who do you let in the house? And then the authorization is what can they do when they're there? So with your example, you would want to use something like OAuth if there's lots of different things that someone could do in the house, and then you want to have that scoped access. Whilst if it's a very simple house and there's not much to do, you might not need that authorization to the same extent. Is that on the right path?
It is, and if we take that analogy like one step further, you can actually think of OAuth as without OAuth, you might have a key to your own house and you can get into it. But if you want to make a special key that a contractor can use to open your house while you're not there, but that only lets them into one room, not all the rooms of your house, that you can think of, that would be OAuth. That's where it's not the same key you have. It's like a special key. It's maybe a smaller key that only works on one door that you let somebody else have because you trust them just enough to let them into one room, but that's it. You don't trust them to go into the rest of the house.
Mm-hmm. Cool.
But if you don't need any contractors to come by your house, or you don't have a cleaning crew coming by your house, and you don't have this use case at all, then why bother building that extra complexity, right?
Mm-hmm.
All right, so if we don't have any questions, we can move right on to the the next section, which is digging more into the technical details of, okay, if this is something I know I need based on everything we've discussed so far, if I need OAuth in my application, how does it actually work under the hood? What does it mean to have an OAuth flow?
Yeah, I think it's good. The only questions are related to more of the specifics of OIDC, which I think we're getting to. So
sure,
let's keep moving.
Perfect. All right, so we talked about OAuth as being introduced to solve this original problem back in the day that some people call it the delegated authorization problem. And I'm going to keep picking on Yelp, even though I'm not trying to vilify them here or anything. It's just a really good, easy example to understand. I said that original flow of asking someone for their real password is like Stefania said, it's kind of gives you goosebumps. It's not a good feeling. It's a very bad security practice. But what's the better way of doing that? How would we solve that today in a way that does not keep anybody up at night or give anybody goosebumps? The way that we would actually solve that today is something that a lot of people you're probably very familiar with it because you've done it so many times without even realizing what it is you were doing. You were doing OAuth, you just didn't know it. The way that it would look is, let's say that you are building Yelp.com and you want to have this experience where someone's going to authorize limited access to just their contact list, nothing else, in order to complete their registration or send an invite to all their friends or whatever spammy thing they might want to do. And the way we would do that is by putting a button on the UI somewhere that says like connect with Google or authorize with Google or whatever it is the provider you're connecting to. I'm just using Google here as an example. What that actually does under the hood, or in the browser rather, is actually redirects the browser. The entire browser does a redirect over to the provider, Google in this case. And in Google's case, it would be accounts.google.com. Accounts.google.com may ask you to log in, maybe if you're not already logged in, but if you are, it probably won't ask you that. The important thing that it does is it gives you a specific question, what we call a consent question, which says, are you sure you want to allow XYZ app, Yelp in our case, to access this type of information, your public email address or your contact list or your photos or whatever it is. In many cases, the provider will even let you like click edit and like, uncheck a bunch of stuff. So you're saying, nope, I don't want to give access to this, only this. And of course, also if the user clicks no, then like we're done talking. Nothing else is going to happen. No data gets exchanged anywhere. But if the user clicks yes, the goal here is to give the original application, Yelp, some way of going to Google and saying, hey, normally I wouldn't have access to this info, but Nate said it was okay that I have access to just this small bit of info or just this small amount of information. Can I have it? So what happens is when the user clicks yes, we get redirected, the browser gets redirected back over to the original application, to a special place on the original application called a callback or a redirect URI, which I'll explain here in a sec. And some stuff happens behind the scenes, which we will also discuss in a sec. And then that application has that limited access to be able to go talk to the API or whatever it needs to do in order to get the user's information, but only what the user authorized them to do. So this, you can kind of think of it as the reason why people often call this the flow is because there's kind of a few steps back and forth. You start at the original application, you get redirected over, you get redirected back, and then some stuff happens behind the scenes. But all of this, everything that's on the screen right now, is really the entirety of OAuth 2.0. Of course, there's some edge cases here and there. It's a little bit different on a mobile device versus a browser and stuff. But if you zoom out, this is really the whole thing. And what we'll do kind of in the rest of this section of the talk, what we'll do is kind of just keep looking at this same exact diagram, but with progressively more and more detail added to it. So we can kind of add in some of that jargon, add in some of that extra information that tends to be really confusing when you first try to understand how this works. But I just wanted to point out, this is like the whole thing. If you can understand this part, you can understand all of OAuth. So let's do that again, but adding some more of that jargon in. We already mentioned one bit of jargon, which is the resource owner. That's a term that means like you or me, the human sitting behind the keyboard. The resource owner is the one that initiates this whole flow, clicks on some button that says connect with Google or authorize my contacts or something like that. When that browser gets redirected over to the provider, what's also called the Authorization Server, there is specific bits of information that's mandated by the OAuth standard. The ones I've listed here are really important. The redirect URI, also called the callback URL, that's where the authorization server should redirect back to when it's done. Because again, this is a full page redirect, so it's not like a pop-up or anything. It's a full page redirect, and the authorization server needs to know like how to get back to the caller once it's done. There's also something called a response type, which is kind of jargony in OAuth. There's different versions of this OAuth flow that have like slight variations. Here we're discussing the most common one called the code flow because it's called response type code. And then the really, really important thing, kind of the OAuth invention, the reason OAuth exists is that there's something called scope. What scope is just simply a space delimited list of some names or identifiers, which means something to the authorization server and is a list of the specific permissions that the client application is asking for. So this differs based on which authorization server you're talking to. Google in their docs have a list of all the scopes that they support. It's, scopes related to your contacts and scopes related to Google Drive and scopes related to Google Photos and scopes related to Google Docs and all sorts. It's very, very granular. But in this case, in our case, the client application might be asking for like the contact scope, which gives read-only access to the contacts, but not write access. That would be a different scope. And like basic profile info or something like that. This list of scopes is exactly what the authorization server uses to build up that consent question or that consent screen that the user must click yes to. So if you've ever been in one of these like UIs and you see some application like, are you sure you want to allow this application to access? And then the bulleted list is like a million things and like it's like everything. That's because what that application developer did was they just like put they overloaded it with like every single scope that exists and they're asking for everything, which is a really bad practice. But regardless, the list of scopes that the client is asking for is exactly what the user must consent to. Assuming the user does consent, clicks yes, we're redirected, the browser is redirected back over to whatever the callback URI or whatever the redirect URI was specified at the beginning of the flow by the client. And it's up to the client to have like, a route being listened to at that URL that's looking for a specific type of request coming back from the authorization server. It's specifically an HTTP post, usually coming back from the authorization server. And what the authorization server sends back is what's called a code. The code is like a kind of a digital proof that the user clicked yes. Obviously, if they did not click yes, it's not included. But if they click yes, it's just a string of, looks like gibberish, but it's a string of information that gets sent to the client. And then the client application, it's up to the client to go do something with that code. Now, it turns out that the client can't really do anything with that code. The only thing that they can do is go exchange that code by talking to the authorization server one more time. They can exchange that code for what's called an access token. And an access token is the thing that the client really needs to be able to go do whatever they need to do with the API they're trying to call or whatever. So the client gets the code. They say, all right, I got to take this code, go one more time, talk to the authorization server, say, hey, I got this code. What I really want is an access token. The authorization server says, cool. I can confirm, like Nate did just click yes. The code proves that. Here's an access token. By the way, it's only going to last for this long. It'll expire after this amount of time, but you can go use it to go do what you need to do. And at that point, now the client can do the thing that it's been trying to do in the first place, which is go talk, in our example, go talk to the Google Contacts API and go pull down my list of contacts. So this is, again, this is the whole thing. We've added some more of the technical details under the hood. And like I said, there are some variations on how this works. It works a little bit differently with single page apps than it does with mobile apps, than it does with browser apps. But by and large, if you zoom out, this is like 99% of the OAuth flow. Now, one question I get a lot, I don't know if anybody's asked it yet, but one question I get a lot here is, why do we have this? What's the need for this extra, feels like an extra step? We went back and forth with the authorization server and we got this code, but then we turned right back around and exchanged that code for an access token. Why didn't we just get the access token right away? And the reason for that is because the exchange step happens using what we call a separate channel, a different channel than the code, than we get the code on. So all of these steps here so far, up until the exchange, we're talking about like real browser redirects. The URL in the URL bar is changing. The browser is redirecting to different systems and coming back. And the way that we can transmit information through browser redirects is like a URL parameter, maybe question code equals whatever in the URL bar, or maybe an HTTP post, but that's really effectively the same thing. There's a little bit of information being sent along with the browser request. That means that in theory, there is a risk of the code being leaked because hopefully we're all building things on top of HTTPS. So these are encrypted connections. So nobody's going to be able to necessarily, see that information going over the wire. But that doesn't mean you don't have a malicious browser toolbar installed, some extension you didn't know about that's watching the page, some JavaScript that's going rogue on the page and sniffing things that are going by. That's all, below, you could say below or above the layer where HTTPS protects you from those kind of things.
And
so, yeah.
That's the authorization code flow, correct?
Correct.
Okay, and that's newer to solve the problem that you just highlighted, or is it not newer? Was that always there?
It actually was always there. Yeah, it's the original, kind of like the original OAuth flow. That's kind of been there from the beginning. There is some newer stuff that was built to solve this same problem, but for single page apps.
Right. Okay.
Yeah.
Cool.
That gets a little tricky, but there's some nuances in like how single page apps work because in a single page app, there is no backend that's necessarily running to do extra processing. And the whole point of doing this exchange step is the code is coming over a relatively secure but slightly insecure channel, the browser, URL bar basically. But the exchange step happens on the back end of the server that's hosting the application. With an HTTP post that's again HTTPS and completely secure. So
yeah, no, that I forgot about the SPA flow with OAuth, but yeah, I remember now.
Yeah.
There's a few questions in the chat that I think are interesting for right now. One is by Brian PDX. Does it ever make sense for microservices in one platform to use OAuth? It's activity of one user inside one system, but architecturally the services are in some sense third parties to each other. So I guess the way I'm reading that question, like internal services using OAuth to talk to each other, does that make sense as an architectural decision or design decision?
I think it could. I think the kind of like no-brainer answer for OAuth is that it's a good fit for external architectures. In other words, if the architecture you're building is like, we have this service, but we're going to have n number of third parties connecting to our service, and they need to use our API, then that's like the classic OAuth architecture. But yeah, this is interesting because you definitely could see internally that different microservices in a big system are kind of like third parties to each other. Architecturally, I think it could make sense. The only drawback I would say it has is like additional complexity. If you're building a system that is so big that different teams that are building different microservices like literally never even talk to each other because the system is just so big, like your Uber, for example, which I think has like thousands or maybe tens of thousands of microservices now. That could make sense. The drawback is that it's an additional layer of complexity. I would say like the whole "you ain't gonna need it" Yagni thing would apply here. Like unless this is like exactly the problem that you need to solve, it's probably an additional layer of complexity you don't need. But in some systems that are big enough, it might be the right solution. I certainly wouldn't do it like just from a practical point of view. If my system had like 3 microservices and I might add 2 more, I would not look at that as a solution. If it had thousands of microservices and I have like 13 different dev teams all over the world that never talk to each other except through documentation that's published for every microservice because it's that standardized, I might look at this.
Right. Don't do it just for the hell of it. Yeah. Come up with a good use case for this. Yeah, that makes sense. Another good question.
Sorry to interrupt.
No,
Just
ahead.
A quick one for me, for the audience. So we do have our competition to get the Udemy course, The Nuts and Bolts of OAuth 2.0 by Aaron Pirecki. So in order to enter, what you're going to need to do is drop hashtag DevSlopLive in the YouTube comments, and we will pick 5 people at random. And also, Barbettini, I know you recommended this course, so I don't know if you have any teasers for the audience about it.
Sure. Yeah, this course is built by a really good friend of mine, Aaron Pirecki. He and I actually used to work together when I was at Okta, and he is one of the top experts on OAuth. He has written books about OAuth and also wrote this course. He is extremely knowledgeable about it, much more than I am. If you want to get the real nitty gritty about how to implement OAuth 2.0 on in a server situation, or you need to build an implementation of OAuth or consume one, I highly recommend all of the stuff that Aaron's written.
Cool. So just a couple more questions around. Whoa, the chat got intense here. I got it.
People took you up on your call to action there.
What are some best practices from the podcast for the lifetime of access tokens and ID tokens, and why?
So I mentioned very briefly, I think when I was going through that diagram, that the authorization server ultimately gives the client an access token that lets the client do what they need to do, or call an API or something. But the access token is not unlimited in terms of time. It will expire at some point. And so it's a great question. Like, what is the best practice around having what the expiration time or the lifetime of those tokens should be? Number one practice is that they should expire at some point. Like issuing access tokens that never expire is a bad practice, because the reason you want an expiration on the token is that ultimately you want the token to be able to be to expire, so that if it got leaked out in the world for some reason, because again, you're giving it to some third party. So who knows if they're having best practices around their databases and their logging and their intrusion detection and stuff. If they leak the access token, then somebody else could do whatever it is that they're authorized to do for that user. Now somebody else can do for that user. But if there's an expiration on it, then at least at the very worst case scenario, whoever got that token can only do that stuff up until the point when the token expires, and then they can't do it anymore. So it kind of puts a upper bound on how bad the damage could be, I guess, if the token got leaked out. Now, how long that lifetime should be is a question that there's not a single answer to. It's like one of those programming things. It depends is a common answer. The reason it depends, though, is because it really depends on what the application is doing and what scopes that token has. So to give an example, if you're building a banking application and the scopes on that token are you're allowed to transfer money or you're allowed to withdraw, those are extremely sensitive things to do. And a token like that, you could argue for an extremely short lifetime on a token like that, minutes at the most, because the sensitivity of what could happen if it got leaked would be so bad. On the flip side, if you're building something that's not banking, is fairly low risk or low amount of headache if the token was leaked, then it's common to have token lifetimes that are 24 hours, sometimes a week. It really depends on the sensitivity of the data, the sensitivity of the application. And I should say that when we say the token would expire after a week, that doesn't necessarily mean that the application gets shut down after a week. It would mean that the application would have to just go back to the authorization server one more time to say, hey, the token expired, can I get a new one? And that allows the authorization server to double check, be like, okay, this user still hasn't gone into their settings and revoked your access. So yeah, it's okay for you to get a new token for another week or another 24 hours.
Yeah. I think we're good if you want to keep going here.
The only thing I was just going to quickly say, because we did have our poll about different members of the audience and kind of their skill level. So how familiar are you with OAuth or OpenID Connect? 82%, including myself. I am here to learn. So that was the most popular. What I found quite interesting looking at the results. So some people knew OAuth, but not OpenID. That was 10%. But no one did new OpenID, but not OAuth. So there's definitely a directional thing. And 6% among us are experts.
Cool. Yeah, that's not too surprising. Not surprising that people would know OAuth and not OpenID Connect because it is the newer one. So that makes sense. So actually, that's an excellent segue because the next part is explaining exactly kind of where OpenID Connect fits in and how it works. I mentioned before that OpenID Connect is for authentication, OAuth is for authorization, and that OpenID Connect is really just an extension or a layer on top of OAuth that adds in the stuff that was missing for authentication and kind of just standardizes it and makes it good for authentication. And I'll go through basically what amounts to the exact same diagram here because, like I said, OpenID Connect is built on all the same standards as OAuth or the same underpinnings, same pattern as OAuth. So it's going to look almost exactly the same, but if you look closely, you'll see like a few small points where the differences are, and I'll point them out as we go. So here, instead of the client needing to go access some data about the user or have some permission to do something for the user, the use case here is the client just wants to log the user in. So instead of a authorize my contacts button, it might be a sign in with Google button or sign in with X button. But a lot of the same stuff applies. So the resource owner or the user still has to click on something in the client. We get a browser redirect over to the authorization server. And unfortunately, that is not a typo. It is still called the authorization server, which is really confusing, unfortunately. But that's just a legacy of the fact that OpenID Connect is really just OAuth with a little bit of extra stuff on top. Still called an authorization server. We still have a redirect URI. We still have a response type, which identifies this as the code flow or the authorization code flow. Same exact thing, no differences there. Really the only difference here is that in the list of scopes, we have a standardized scope name called OpenID. And if the provider implements or uses OpenID Connect, they must have a standardized response to that OpenID scope. That scope identifies this request as an OpenID Connect login request or authentication request. Now, the authorization server may still show a consent screen to the user, especially if it's like the first time that they signed in with this app against this provider. Same deal as OAuth. We still get a code sent back to the client application, which again, the client can't do a whole lot with other than an exchange for an access token. This part is also a little bit different because we use the OpenID scope. The authorization server, when the client does the exchange step, will respond not only with the access token that they normally would respond with in OAuth, they also will respond with something called an ID token. And the ID token is the new part that OpenID Connect standard adds on top of OAuth, and it fills in that gap where OAuth didn't have a way to query the user's information. What the ID token has is a very standardized schema. Like you must follow this exact schema for ultimately some JSON blob, a payload that is contained in the token. And it contains like the user's email address, name, some super basic information, but that is the information that you need for logging in, for signing a user in. The contents of that ID token is what allows the client app to then, basically disappear the sign-in button and say something like, "Hi, Nate," and display the name of the user that just logged in, and probably on the back end, save a record in the database. If this is the first time that user logged in, create a record that's like user's name, email address, they signed in via this method or whatever, so that you're effectively completing a registration on the client using this information from the ID token we got from the authorization server. So that is the entirety of OpenID Connect. Again, there are some edge cases here and there. There's some nuances if you're on mobile or SPA, single page apps. But this is the entirety of what OpenID Connect changes from OAuth. It really adds a new scope. It adds this new behavior of returning an ID token. And that is the mechanism by which the client gets information about who just logged in, which is the whole point of authentication. And that's really it. There's more. There's obviously more that we can go into if folks have questions about how these flows work or nuances about how they work in certain situations. But that is the technical underpinnings of OAuth and OpenID Connect, as well as hopefully some helpful information to understand kind of where they fit into the big picture when you think about using these or not using these in your applications. But we can definitely open up for questions. I know there were a few we held to the end, so let's do it.
Yeah, not a question, just a comment, because I was new to OpenID Connect. This is very nice. Looks very clean. I like the way the architecture is. So, I'm a big fan.
It's like one of those things. It's like clean on paper.
Always.
Clean on paper. It tends to get a little messy in the implementations, but OpenID Connect has helped a lot with that because it forces the implementation to be a lot more standardized when you're talking about authentication.
All right, let's see. Questions. SPA apps. So there is a question on the SPA conversation. So I know we didn't talk about PKCE, but is that, should we maybe like have a short kind of, I don't know, I think you'd be probably in a better position to do this than me, like security considerations around SPA apps and where PKCE might come in. And
yeah, definitely. This is the fun part. It gets like way down in the weeds. So yeah, PKCE, actually we should talk about mobile apps first, because that's where PKCE started from, and then we can talk about SPA, single page. So really brief discussion about mobile apps. OAuth and OpenID Connect became popular to use for mobile apps because it's even more common in mobile apps to have like a sign in with X button, sign in with Apple or sign in with Google, because mobile apps want to like reduce the friction of registration as much as possible. So that became really popular. There was a specific vulnerability only in mobile apps involving how that final callback URI or redirect URI worked. Getting back into a mobile app, because it's actually kind of, for anyone who's done mobile app development, it's kind of awkward with like if you open up a browser and then you want that browser to redirect, but the redirect has to go back to a native app from the browser. You end up having to use like a native app URI where it starts with like the app name : / instead of HTTP. I'm probably showing my like rustiness on mobile because I haven't done mobile in a very long time. But regardless, there was a specific vulnerability where another app on the system, like installed on your Android device or your iOS device, could spoof that redirect URI or basically intercept it before the real app got it. And it was like another way that you could try to steal that code as it came back from the browser. So to make a long story short, there was an additional kind of extension added for OAuth and OpenID Connect called Proof Key for Code Exchange, PKCE. And I don't say this often, but it's one of the specs that's actually like pretty easy to read, or it can be an enjoyable read. It's very short, unlike many specs that are like hundreds of pages long. If you Google PKCE spec, it's like 7 pages or something. It's like clearly lays out, here's the problem on mobile, here's how we're solving it, here's the solution. It's one of the few specs I've ever said was enjoyable to read. Basically all it does is it makes the client generate one extra bit of information, a hash basically, that it sends to the server. And the server, I'm gonna butcher this probably because I haven't looked at it in a minute, but the client generates a hash locally, the server generates a hash, and they must match at the end, which basically cuts any rogue app that's trying to intercept the communication would not have the same hash. So it kind of cuts that vulnerability out of the loop. So the interesting thing, to bring it back to single page apps, is that mechanism for generating a hash and sending it through the flow and verifying it on the other end of the flow is a relatively simple mechanism, but it also kind of inadvertently fixed another problem that was out there in the wild, which is that in single page apps, for a long time, the standard practice was to use a slightly different flow than what I showed here in the diagrams, called the implicit flow. as distinct from the authorization code flow, which is what we looked at. The reason people use the implicit flow on single page apps is because the authorization code flow needs that exchange step to exchange the code for an access token. But that exchange step is supposed to happen on a server, like on the back end of a web app. That's all well and good if you're using a server-side rendering framework like Django or Laravel or ASP.NET or Express.js. But if you don't actually have a backend, if it's a single page app where it's all running in the browser, you don't have a way to do that exchange step. The implicit flow kind of cuts that exchange step out and says, well, maybe it's not so bad if we just redirect, like send the access code directly back to the access token rather, directly back to the client through the redirect URI. It was never anybody's favorite solution to that because the whole point of doing that exchange step was additional security around getting that access token and keeping it safe. The implicit flow, but it was kind of a compromise to say there's not really a better way to do it for single page apps right now. So like, I guess we'll just do that. What now, like to finish this long story that I was trying to make a short story was that there's a new method or a new way that's becoming a little bit more standardized now of doing a flow more properly in a single page app that involves using this PKCE extension for OAuth or for OpenID Connect in this case to do that bit a little bit more securely. I actually have a video with Aaron, the guy who made the course that we're giving away. I actually have a video on YouTube about this whole topic. We go into a little bit more detail about it. He can explain it much better than I can. So if you hop on YouTube and search for like Aaron Pirecki PKCE or my name PKCE, you would find that talk. It's like 10-minute little conversation we had about it. And that would explain it probably better than I can right now. But just to kind of explain or zoom out to the big picture, there are some considerations for how you want to do this correctly in a single page app, and they've changed fairly recently.
Yeah, I think I found it. I'll drop it in the chat.
Perfect. We have a question. Sorry if I say your name badly. Stuti Kanadia, what other problems does OpenID Connect solve apart from delegate authentication? How does it help if we use OpenID in our web app?
That is really the problem that it solves. You could say that it kind of also solves a problem of if in your architecture it's desirable to kind of decouple the application and the authentication method. In other words, if you want to have an application that people can sign into, but you want the authentication piece, like the authentication service or whatever, to kind of run separately, or it's managed by a different team, or it needs to be used by multiple applications. If there's some reason to like decouple it and put it in its own separate place, then OpenID Connect you can think of as it's like a nice bit of a nice standardized glue that you can use to glue your authentication mechanism to your application. Again, I would say that if you have like a relatively simple application where you just need one user to sign in, that's all they do. They're not trying to sign into a portal and access multiple applications or authorize access to a separate API or something, then it's probably some extra complexity you don't need. But if you already know that you need to decouple the app and the identity system, basically, then OpenID Connect is super standardized. So it's really nice. It's a nice way to not have to reinvent the wheel and kind of glue those two things together.
Cool. I think we had one more question about saving the token in the SPA app. So Brian, PDX, where do you save the access token? Hard to protect it from cross-site scripting. So how do you handle that situation?
Yeah, this is a fantastic question, and it is. I know that It's actually an area of active, I guess you could say, development work or active discussion in the OAuth working group, if I remember right. Because single page apps are really, really common. They're really popular. There's this kind of awkwardness where, like for the reasons I mentioned before, because there is no backend, it's harder to do the code exchange step. So that means when people do workarounds, or they just use the implicit flow and just say, you know what, we're just going to get the token straight back from the authorization server. There's this other bit of awkwardness where it's like, okay, if since we're again using a single page app that's only running in the browser, we need to hold on to that access token so we can continue making requests. But where should we keep it exactly? Because browsers are famously insecure. Like I can just look over somebody's shoulder, hit F12, see the developer tools in the browser and look at whatever cookies are there, whatever is in local storage, whatever's in memory. So there's a question, it's a great question around like, what do we do if we do need to get an access token in a single page app, what do we do to keep it safe? So I would say like a good way to think about this is kind of progressive levels of kind of climbing up the security ladder. The very bottom of the ladder is like, obviously you got to use HTTPS. There's like no argument for not using HTTPS nowadays, I think. The more that you're able to lock down, use modern security headers to lock down your application to prevent XSS attacks, use a content security policy to really lock down like who's allowed to run scripts, create an allow list of like specific domains where you're allowed to load third-party scripts from, or no third-party scripts at all, whatever the case may be for your application. Content security policy and the other security headers that you can find good info online are all kind of ways to plug different holes where browsers can leak or run bad stuff or do malicious things. There's also stuff you can do, as Brian mentioned in the question here. You can save cookies with HTTP only flag, which means that they're not even accessible to the JavaScript engine in the browser. That's awesome, but the only caveat to that is that you must have a backend to be able to do that. The backend is the one that sets that flag, so it's kind of a catch-22 if you don't have a backend. There is local storage that you can store whatever you want in, but that kind of the reason we say it's vulnerable to XSS, cross-site scripting, is because like if somebody else manages to get some script to run on your page, then the contents of local storage are fair game. Like you can just do local storage dump or whatever and just enumerate everything in local storage and it's yours. So there's not like, I wouldn't say there's a single super great answer to this. It's a matter of, if you're in this situation with a single page app, I think the number one thing you can do is make sure that all the obvious stuff is plugged. All the obvious holes are plugged. Encrypted connection, HTTPS, all the security headers you can manage to get to work on your site without breaking things, you should have turned on. As tight of a content security policy as you can. Those are all like good ways in modern browsers to reduce the attack risk or the risk surface as much as possible.
Such a multifaceted question, but yeah, I think you hit all the big points there on protecting that piece of data.
Cool. I have a question that's it's complementary. So instead of how we're saving it, so this is I'm getting all the good names. I'm Decima Tamar. What best practices do you please recommend on how to revoke access for a self-contained JWT token?
Right. Besides the fact that it will expire, right? So we talked a little about token expiration. We talked about how forcing the token to expire kind of helps put an upper limit on how bad it would be if the token was leaked, right? Because then you're like, well, at least it's going to be bad. It'll be shut down by the end of the day or whatever, or 10 minutes or whatever the token expiration is. But sometimes there's also a desire to be able to say, let's say we know a breach occurred and we're like, okay, yikes, we know that like these users were compromised or this application was compromised, or even not even a breach. It might be like this user got deactivated or this user was, fired or something. In any case, we might want to say the tokens belonging to this user that have the tokens that have kind of been issued out in the wild relating to this user or this group of users. We want to not wait for them to expire. We want to deny list them right now and make it so that even if they technically haven't expired yet, they won't work. And by won't work, I mean if the third-party application tries to make an API call using that token, it fails. This actually ends up being another thing that tends to be a little complicated because there's a trade-off. And the trade-off is it's kind of a trade-off between speed and security. You can either have it fast or you can have it revocable, but it's hard to do both. The reason it's hard to do both is because one of the nice things about having a token that has its own kind of built-in expiration is that let's say that the API that's looking for this token, like I'm the Google Context API or whatever, I'm looking for this token to come in. If all I have to check is the expiration of the token, then that's a very fast check. But if I also have to check the expiration and then go call some other, the revoking microservice, that's an extra hop. Unless I happen to have the revoke list, with me. But in large systems, that would hardly ever be the case. So as soon as you want to have a centrally located revoke list or deny list that you can add tokens to revoke them, then that means that all the services that consume those tokens need to go check against that, which means that every single token you check is going to be slower, because how often and it's a trade-off, because how often are you going to revoke? Probably not that often. Maybe 99.99% of tokens you check are not going to be revoked. It only matters in that 0.01% of tokens that you must, it's an emergency and you have to revoke them. But you're trading off every single API call is going to be slower now because you have to check that every single time, even if 99.99% of the time the check is going to come back and say, nope, it's fine. So this is the reason, that's kind of the inherent trade-off there, I think. And that's not to say that you shouldn't do this. I think it is really important in some applications, but it's similar to the question about token lifetimes, because in both the lifetime question, how long should the expiration time last, should these be able to be revocable, those are all really depend on the application and how secure it needs to be. Obviously all applications should be secure at a good level, but if you're building a bank, it's a very different security environment than if you're building a fun little Reddit bot or something like that. The security requirements really drive, I think, whether you need to, which side of these trade-offs that you need to come down with. In terms of, to make sure I answer the question fully, in terms of a best practice, revocation is not really it's not really difficult. It's just a matter of checking on if you're implementing a server, you need to check that revoke list every single time. That's what it comes down to. So that's about it. I think the trickier question, a trickier thing to think through is do you need it or not?
Cool.
Cool. We've got one question from earlier before we kind of wrap up.
That's right.
So this is from the podcast. How is an app using OIDC creating user sessions? And how is the app session linked to OIDC provide a session for that user? I think I said that right.
This, I don't have a slide that kind of demonstrates this, although a diagram of this would probably be really helpful. This is a good question. The short answer is that both the client application and the provider have their own sessions, and they're not necessarily tied to each other. And for anyone who is kind of confused about what this means, let's imagine you're building an application, but you're delegating delegating authentication, got to get it right, to somebody else, to another service. So when the user logs in to your application, they're also going to be logging in against the provider, Google or your own centralized identity provider or whatever. What ends up happening is that the provider has a session for the user, like how long they kind of consider them to stay logged in for unless they specifically log out. And your application also has a session for the user or how long you consider them to be logged in. In my experience, it's kind of hard to synchronize the two. Like OpenID Connect doesn't, as far as I remember, doesn't have any method of like automatically synchronizing the two to like if they logged out of the provider separately, like in a separate tab, would they automatically get logged out of your application or not? That's not really what OpenID Connect tries to solve. I believe OpenID Connect does have a way to check if the session is still active on the provider. I'd have to double check that. I believe it does. But to keep things simple, I think I would say, like, if you're building the client side, if you're building the application, what you should think about is you should think about whether or not the user still has a session on the provider actually shouldn't matter too much. You should have your own mechanism on the client to establish a session for the user. A common way of doing that is to have a cookie that you drop in the browser that represents the user session. That is something that the client application should manage itself. The user may still be logged into the provider, and if you have to go back to the provider to talk to the provider again, you may find out if they're still logged in or not. But ultimately, what it comes down to is they are distinct sessions, and at least in my own experience, this is like not advice per se, but in my own experience, it's trickier. It's more trouble than it's worth to try to keep those like completely in sync. It's easier to just say, I'm going to manage the user session for my user on my application. And maybe they're still logged in. Maybe they still have a session on the provider. Maybe not, but that's okay. I can work either way.
Cool.
Awesome. Well, I've got a long list of thank yous. So thank you so much, Nate. This has been a really great session explaining OAuth, OpenID, what they are, when to use them. Thank you to our audience for all of these great questions. It's been really interactive and we love these types of sessions. So thank you to everyone. Thanks to Nikki, thanks to Nancy behind the scenes, and also to all of our winners, which you can see at the bottom of the screen. Please do get in contact so that we can give you your Udemy course prizes. In terms of, we do have a show, our show kind of next week, that will be testing your assumptions with Red Training. So we look forward to seeing you there. And then Nate, any final words for the audience closing kind of your session? And thank you so much for being here.
Of course, thank you for having me. This is great. I love talking about these things because they're like legitimately can be very confusing topics, and I love like helping people have just a little bit extra knowledge in their back pocket when they come into contact with these things in the real world. So thanks so much for attending. I'm on Twitter. I think my Twitter's down here at the bottom. Feel free to follow me or tweet me questions that you have. There's a longer version of this talk that has a little bit more of the like technical nitty-gritty details. So you can find that on YouTube. But thanks so much for coming. I had a great time. Thank you for having me.
Awesome. Thank you so much.
And thank you for being here. And thanks, Stefania, for your hosting. And cool. We'll see you guys next time. Enjoy the rest of your day.
Next week. Bye.
All right. Bye-bye.